So our interest is to understand the future of, say, network security, including physical layer security, including quantum theory, quantum mechanisms, quantum technology. So now it's your turn.
Yes.
How can we get there?
I mean, it hasn't been so long ago that I was on stage. So I'm from Deutsche Telekom and working for T-Labs and investigating for quite some time now different possibilities to create quantum secure networks and embracing the common technologies that are around and trying to build, let's say, a solution that might work on the larger scale.
So again, also my name is Ángeles Vázquez. I'm with Autonomous University of Barcelona, but also with the Institute of Space Research of Catalonia. And I've been working for many years in security at the physical layer, but mainly in space for space communications. And I do system design and protocol design, but I'm very interested in quantifying security, as I think I mentioned during my talk. And lately, I am quite interested in the fact that maybe it should be more interdisciplinary. And instead of the different communities doing their own thing in an isolated way.
Hi, I'm Karolin Varner, Rosenpass EV and Max Planck Institute for Security and Privacy. I came here when we had our first conversation about having this panel. My topic to drive home was going to be, hey, we need to hybridize. I think that has been done enough. We are all agreeing that hybridization should happen. So now the point that really interests me is what is the methodological basis of the research that we're doing? How can we actually not just add security as in like, hey, let's add another layer, let's do more, but how can we actually decide how to really methodologically reason in a well-funded way about why are we doing the things we're doing and why is that actually really useful? Because all the technologies I've heard today, there are real ways to use them. And I think in order to have the best statement about motivation, we need to get that clear.
So Dan Kilper, you just heard me talking. So if you didn't get the big picture there, right? So QKD is an application for me, right? And I'm interested in making optical networks and making them as efficient and capable as we can. And so moving that technology forward, which ultimately changes the equation of, okay, QKD is this expensive, difficult to use technology to making it something that's low cost, ubiquitous and easy to use, right? So
it's a big challenge, right? To get things together. Are there any ideas how we can take the next step, let's say?
I believe currently the cryptography is a success. No, classical cryptography is our reference, right? So and it's based on mathematics, right? It's a different mathematics than, for example, information theory. It's a fact, no? So then I would say that if we want to integrate both things, we should somehow put the two math frameworks together somehow. So that would be like how to do that. Because they're very different, not only mathematical framework, but even ways of reasoning, of logical reasoning. So I don't know.
I have nothing to add to that in particular. I fully agree. I would add on top of that I think there is a lot of ways we can secure communications right now using some of these technologies that aren't super expensive and that might actually allow us to bring them to more mundane usages than sending satellites into space and having big communication, even though that's a great idea. I love space, but I love it. Like that's, I'm going to tell you the story about what I wanted to be when I was 5 later. It involves astrophysics. No, but I think there's ways to use those technologies right now that can be very useful. And I think there's ways of making it more accessible to people. And for me, that's also always something super interesting, just allowing people also to play with things makes it just so much more exciting.
Yeah, I just remember the slide that I had where actually the next steps were on, yeah, at least for the PQC kind of things where it was displayed as come somewhat endorsed by the security agencies, brought forward by the standardization bodies, yeah, with task force work groups already active. Also for hybridization, this is happening as far as I'm aware. And even in the telco space, yeah, so the telco companies, yeah, where I work from, I mean, there is activities going on. Yeah, so in principle, the train is running, yeah, at least for the crypto part. Yeah? And for QKD as such, or quantum optical or physical layer, yeah, I mean, there's still some work to do, honestly. Yeah, so I mean, we don't have standards, we don't have certification. It's still in research stage, yeah. And as long as it is like this, I mean, there is some more fundamental work to be done, yeah. But when it's done, and we have, let's say, the confidentiality that we have good systems and good networks and also good network integration, yeah, into the rest of the infrastructure, then yeah, there will be probably niches, yeah, that this will be deployed to, yeah, maybe for special customers or for special applications, maybe something we don't even know yet. Yeah.
So maybe I'd push back on just a little bit of what you said there, because you used the word done, which as someone who's doing research, we're never done. Okay. Right. So I think there's a, okay. There's a, maybe you're using done in the sense that it's delivered, the first generation is delivered, right? So we need to evolve the technology over time, and so we'll continue to improve it and so forth. I guess an interesting question is, at what point do you have that minimum viable product that it starts to, you know, in the semiconductor world, they often look at when does the volumes ramp up, right? There's an adoption curve, right? And you're looking for that big exponential increase, and you say, okay, it's been adopted. And right now we're still down in the early tail of that. And the question is, will we get to that exponential increase or not, right? So we're still kind of.
If I may add to that, I would like to add a question about the minimum viable product. I would like to add a question about the minimum viable customer.
I mean, there are application areas, yeah, that are somehow identified for minimum viable customers, yeah. I mean, network operators, yeah, that have their computing centers, let's say, not so far apart, maybe in the city, could be a use case. Financial industry is interested, yeah. So I mean, the first queries are appearing, maybe car. Yeah, could also work, but I see this more in the PQC space, by the way, because they're mobile. Yeah, yeah, that's it. Yeah, so obviously government, yeah, with the EU and the big programs, and at least I know from the German government. I mean, they're also the scouting projects running. Yeah, and they're looking at the technology and. Try to find out and get ready. Yeah, minimum viable product. I mean, it's for key exchange, it has to work at the end of the day. Yeah, so certification, standardization, product development, maybe not just one vendor, interoperable vendors. Yeah, would be kind of cool from a telco operator perspective, because we never built on one vendor. We never did, and we probably will never do. And at the end of the day, I mean, a working integration, yeah, into, let's say, then the encryption or application space. No?
If you don't mind me asking, then, so we've got 2 vendors at least, right? And actually in the system space, more than 2 vendors, right? And you've got the stuff in your lab. So what's preventing it from just being sold everywhere and used everywhere? Do you have a sense, or?
What I'm aware of is that for the governmental use case, let's say EU or EuroQCI, the EU is actually requiring European vendors. And the vendors that I had in my lab, I think at the time being, they're not qualifying for that EuroQCI initiative. Yeah, so there's a quest for startups. Yeah, coming out of Europe, and I mean the reason is clear. I mean they want to have, let's say, the complete openness. Yeah, open sourceness as you had in your talk. Yeah, for crypto, this is also wanted for the QKD systems. Yeah, otherwise you cannot qualify or certify them. Yeah, that's one of the big problems. Yeah.
So I'm curious, since you have QKD devices in your lab, and you're probably in good contact with the vendors, did you ask them, like, hey, if you want to get verified open source parts of your software stack, or like open up some of the hardware so the BSI actually approves it? Or is it?
A funny answer. We asked for the root password and didn't get it. No, it's an issue. Yeah. I mean, the completeness of the systems and the non-open sourceness is an issue. Yeah. So I'm not too much into this flagship project that we're running, this demo quant, yeah, the Bonn-Berlin link, the long one. Yeah. They're also, let's say, they're probably better contracts with the vendors. Yeah. So maybe they have a chance to look in, but I don't know. I cannot say. Yeah. I don't know.
Do you know any vendors, maybe some vendors you don't have in your lab right now, that are more open to that? Because like, me as a researcher, I would always go for the one that I can research the most, I guess. So
I heard that Optics is quite open. Yeah.
Okay. Thanks.
At least, I heard this yesterday when we went at the PTB. I mean, they're actually as open that they discuss issues with the detector and the time gating. Yeah.
Okay. I actually didn't have an answer. I had a question, and I was interested, and we heard a lot about QKD in fibers today. I thought you might have some information about QKD in space. Oh, I'm super interested in hearing it.
What would you like to know?
If you ask like this, how well does it now? How expensive is it? How much data can I pass through the thing? How sure can I be that my spaceship is secure when I have nobody there actually checking?
Well, to be trusted, for a satellite to be trusted, this is known. You at this until now, you just need to have control in the supply chain and who is building the different parts. Usually, there is the platform part, which is simply to have the satellite orbiting. And then you have the payload, which is the intelligence. No? So far, they were independent things. But now for the QKD, they should not be that independent because you have to have control also of who has built the platform. And then what we also realized is that the attacks, as you were asking before, can be different. Okay, because there are also new threats for satellites, as you all may know, that there are new ways to attack satellites, and so we have to look to all the attacks in the standards and the papers, and then we have to add our own standards, our own attacks, and try to modify, because I work with the hardware people, and the hardware people are trying to modify the hardware to also to be able to solve these attacks. But then also one of the most important things is that the satellite moves very quickly. So then you have a lot of additional noise. And sometimes what you have is that there is no key. So it's impossible to generate key. And that's and then the typical algorithms for generating the key in assuming fiber do not carry over to the space systems, and that's why the QKD have to be modified. The protocol has to be modified a little bit, but we are working on it now. It's exciting, but in any case, I take the opportunity to insist about the quantification of the security, because if we all agree in this hybridization, how do you quantify the security that you sell to the customers? How do you tell them, look, this is secure up to how you sell the security? Because up to now, most of your customers, I think they don't understand the quantum technology. So they will trust you what you tell them. So what do you tell them?
The customers really don't want to know. Sometimes I have the feeling, yeah. So it simply has to be secure. Yeah? I mean, they're paying for a product, and I think there's limited willingness to pay for extra security. Yeah. So people normally think I'm paying for my contract. I expect that my communication is secure. Yeah. And it has to be done. Yeah.
Mark, I think we should definitely always specify who's the customer. So you probably meant end consumer?
Company, yeah. I'm coming from industry, yeah. So for me, the customer is the customer.
Yeah, B2B.
Yeah, B2B or end customer, whatever you like. Yeah.
Because I mean, sorry, 1 second. So I mean, I'm an customer, or end consumer. So I totally agree with you. I mean, I wouldn't really want to pay a lot extra. But since our services are being offloaded to the internet, like all the money is flowing through the internet, I would expect that huge, say, commercial platforms would actually want to ensure that nothing goes wrong when people buy from them. So I would, my feeling is they would probably want to pay a bit extra. Is that true?
No. Companies never want to pay extra. Do you want that? No, yeah. Nobody wants to pay extra, actually. Yeah, this is negotiation. Yeah, I mean, this is in principle a service agreement, SLA, OLA, with industry customers that you have to negotiate. Yeah, what's in there, right? And what the price for the service is. But it's, at the end of the day, security, I mean, don't get me wrong, security is really, really important. Yeah? And for my company, it's tremendously important. It's so important that they put it, let's say, also on their PR statements every once and then. Yeah, so cloud from Germany with German data privacy requirements fulfilled and blah blah blah. Yeah? All that. Yeah, so security is important, but at the end of the day, I mean, if we talk now about a QKD network installation, this is really, really, really expensive, right? And that's why I think there must be good reasons, yeah, for spending that money, except for, let's say, other solutions if they would be available and would fulfill the same needs, right? So the money has to come from somewhere. Yeah.
So coming back to your initial question, I think it's about what is our methodology. My methodology is what I shared this morning: security proofs, reduction proofs, and what we use as a metric is usually an advantage term. I'm not going to go into what that means precisely. I agree with you, though, that nobody gives a damn in practice. And I think that harkens back to that idea of transitions in methodology. If you're in cryptology, you deal in advantage terms. If you're in computer security, you might deal in CVEs, vulnerabilities per year. If you're in industry, you might do standardization. If you're a lawyer, you might deal in remuneration on case in case something was broken. And if you're a person, or if you're like any person really, I think you deal in trust. And what we usually don't do is really think through how do we take that entire pathway from the advantage statement to trust in the end user. And there's a reason for that. I spent 10 years in industry. I've never heard a security company make a claim that wasn't entirely bullshit. It's all snake oil. It's an industry that is strategically destroying trust by spewing out bullshit. And it's extremely hard to deal with that because I'm not getting any funding for science communication. I'm just getting funding for, hey, implement this thing. Oh, that science communication aspect, sorry, that can't really be funded. So as long as the communication is handled by end user by companies whose only interest is in marketing, we're not going to get much trust.
You want to be controversial, perhaps. I think as someone who I used to work for a system vendor, and still know a lot of people there, and I know that there are a lot of people that are working very hard to test out their encryption and security that they implement within the system, and they're required to do this by their customers, right? So, so there's some sort. I don't know exactly what they test, and I couldn't say, what they're verifying, but they're certainly testing the heck out of their systems before they release them and this kind of thing.
Yeah, but maybe what they are testing and they are getting something, they call it somehow level 13 of security, that who knows what is that. And then she also gets a security measure saying advantage of something. And then I also get an advantage, a quantum advantage that I quantify with a number. But none, this guy's, not her advantage and my advantage is the same thing. So that's an ambiguity here. So there is, this ambiguity. We are now in this ambiguity, right? And this is the why we need a methodology to fix this. That we all are in the same logical. Because I also think, because I have also master in logic. So since we are moving from classical to quantum, and we are still reasoning in the same way as where we have classical telecommunication, I believe we have to move to some other type of reasoning, right? That to fix this ambiguity, because this ambiguity is because we are coming from different, and classical. Sorry for the philosophical.
Okay. So, in an ideal world, there would be social scientists cooperating with the not so social scientists like us in coming up with ways to measure impact of various security schemes. These findings would be disseminated to the governments, who would then create regulations for the corporations, which would then drive our research in order to fulfill the security that are required, that these regulations would require. That would be the ideal world. Unfortunately, we don't live in an ideal world. We have money involved everywhere. And really what the companies look for is ROI. Bruce Schneier, who some of you may know his blog, I disagree with him on many points, but there's one point he continually makes, and that is, we get what we pay for, and we don't pay for much. So that's basically, as long as it's not like, how did the money laundering laws came about? They did not come about to protect us. They came about to protect the companies because they are the ones who paid money to the governments to do this. So perhaps, we're kind of stuck here. I like the fact that we do all this research, it's fantastic, and maybe something good will come out of it. But I would not be surprised that nothing ever gets done. Such is life.
One might say that no one cares until something bad happens.
So I think we are in a world where social scientists are paid to actually look at the impact of cryptographic systems. There's a group in Hanover where I live. There's also a group at Max Planck Institute, and I talked to the head of that group yesterday because I'm trying to hang out on that floor just to make things happen through serendipity, basically. It's not just a problem of money. There is money there in a lot of places. It's also a problem of alignment. Literally a similar alignment problem as in AI. We have systems of valuing contributions in a scientific discipline, like for instance, usable security. And then I'm talking to the usable security people, hey, can we do a project together? And they have their publication venues, we have our publication venues, and we can't do something together because if we publish in their publication venues, it's not going to give us brownie points and vice versa. So we're not incentivized to work together, even though everybody agrees if we work together, it would be great. They agree it would be great. We agree it would be great. Administrators love interdisciplinary action. We still have these reward systems. So I think security at scale also means looking at empirically looking at what do the social systems of security, the social systems that we interact with actually produce. Maybe we can get some of the AI researchers to look at that, and maybe we can get some more funding if we put the right terms in there.
So actually, the EU has a really nice program for 6G that's part of Horizon Europe. They call it the Smart Network Services SNS program. It's joint between the EU, the Commission, and an industry association that they created. And because of the Commission's involvement, so that the industry is in there because they have to make the stuff at the end of the day, and obviously they have the conflict of interest that Bulat was mentioning there, but the Commission's in there too. And so they're putting a lot of emphasis on what they call KPIs and then KVIs, key value indicators, and trying to understand from a social science point of view, what's the value that society gets, and then translate that to KPIs for our commercial system, for our technological systems. The challenge, what they're struggling with in a huge way right now, is making that connection. Well, first off, well defining the KVI, and then making the connection between the values and the KPIs is really challenging. But I think they're creating an environment where we are engaging social scientists with engineers and scientists and trying to develop that. And what I'm not aware of is, and I've seen it working on kind of the radio and optical communications side. I'm not sure about the security side. I know that there are some security strands in there. I don't know if others have experience with that. Is it something like that happening in terms of these research projects related to security? Do we know?
I don't precisely know. I mean, there's a lot of different venues of funding for security projects. Horizon Europe actually just abolished one of the biggest ways to fund open source projects. The Next Generation Internet program was abolished, and now it's been replaced by AI research, which I'm not super happy with. There is a growing movement of people trying to push for that, trying to push for these sort of integration things. Security also is kind of a cash cow, so you can make a lot of money with security, and there are actually some good companies, as you pointed out before. I think one thing that we should really be cautious about is numeralism, this idea that we have to measure everything in order for it to be valid. I think qualitative methodologies are great, and instead of trying to come up with like some function that's going to put a number to how effective is the research, you could also pay people to have opinions on how good is the research going and have them produce text output. I think these things are called papers. Without like giving qualitative assessments that are not going to reduce the actual effectiveness of things to dimensions that may or may not be the important dimensions.
Then so let's assume we would meet next year again and have the same panel. What would we have done in between? You know, what would have been the deliverables? For example, we could say, Mark, next year, tell us a price. You know? Yeah. I mean, what's at which price tag will your customers jump in and say, okay, I buy that thing. I buy that small extra because what? You will probably need a selling point. What could we others sell to him?
That would be what I would like is that, for example, we come up with an advantage we both agree is the advantage, because at the moment I think she comes up with an advantage, okay, with some reasoning and proofs, and I come up with a completely different advantage, which I call the same way advantage, based on completely different assumptions and mathematics and everything. So my dream would be that we agree in the same ground, right? And we come up with the number that then we tell you, look, this is a number you have to tell your customers, or with which your customers can trust you, trust the security you sell.
I see it more coming from the customer. Yeah. So normally it works in a way that there's a market pull. I mean, there are two sides of things. One is the market side. There should be a market pull. There should be customer interest. If no customer is coming, what shall we do? Yeah, I mean, we can put a price, but it's not interesting for anybody. Yeah, there has to be an industry research, something that is actually having a need that can be fulfilled, let's say, with a quantum optical network or with a new security scheme or so. Yeah, to build a large scale platform in the telco space. The other thing is, what do we do for our own networks? Yeah, because we have this security promise, yeah, to our customers. Yeah, so they think, they believe, and they should believe that we do everything we can in order to make the communication private. Yeah, I mean, this and secure. Yeah, and this part is in principle our own. Our own business, yeah, but not the business of my company alone, because the telco doesn't work this way. Yeah, so I mean, this is happening in all these standardization bodies like GSMA and Europe, and yeah, and let's see, yeah, and that's a negotiation between all the telco operators and vendors, because at the end of the day, I mean, you just don't drill in, let's say, PQC in one of the apparatus, but you want to have this with interworking, working the same way for all telcos, and therefore vendors have to put it in and so on. So it's a big initiative that needs to be aligned, yeah, and yeah.
I think this is the closing round, isn't it? Okay, so what do I want to achieve in the next year? When somebody asks me what do you want to achieve in 5 years, I usually say, I see myself on a sailboat in the ocean.
Next year, this panel.
We have it on the beach. Sorry. Good reasons to have more people here. No, so I mean, well, I want to be in a year is I want to have a published paper together with Paul about the concept Paul put out beforehand. I want to have an organization. Rosenpass EV is also an organization that has a bit more of a diverse array of cryptographic constructions that we're working on. I want to have more connections with different types of researchers to talk about subjects like QKD, and I want to have sort of a platform for this type of shared engagement. And I really hope that there's going to be some way to reach out to even more groups, not just scientifically minded people, maybe some amount of industry, but also the people who really in the end would be the end users, the people who could benefit from the technology, to really figure out how do we make sure that the cryptographic systems that we build at Rosenpass do not just benefit corporations, but are actually having an impact on people's lives. I don't think QKD is necessarily the point where this is happening, but for me, this is really something I always try to keep in mind. How do we make sure that the stuff we build is globally useful to real people?
So I think a year is a little short, but I would say that with the hopefully next year we'll have some experimental results coming out of Ireland is one of the things in what we were setting up, and we can talk about that, and we'll be and really I'd like to see the whole kind of quantum wavelength routing and assignment problems really taking off in many different directions and progressing that networking paradigm, which I believe that in roughly 5 years, if I can go out that far, IBM will have a 1 million qubit quantum computer, and there will be many applications using that, or not. But that's their roadmap. Either they miss the roadmap and everyone is like, well, what's this quantum stuff?
Is it error corrected or physical qubits?
That's physical qubits, which will allow you to do a couple of fault tolerant qubits, but that's kind of the start of it. But at that point, and they will get there by using networks, and so there will be entanglement distribution networks connecting quantum computers within data centers, and there will be, I think, intense efforts to move outside the data center in a more distributed environment. And so we'll see quite a bit of activity that I hope will be taking this research and starting to develop it into commercial entanglement distribution. And where QKD will fit in there, I'm not sure, but perhaps it would then be offered. So all your optical system vendors will be starting to develop their entanglement distribution solutions. And I suspect that QKD would be an option that is included in that. Right? And by that time also, the EU will have, or not, deployed their Euro QCI network, and we would have a European-wide quantum key distribution network.
Okay, more short term, I would be happy to see by the end of next year a QKD system being certified. Yeah, through the PP. This would be really cool. Yeah, because this would put the whole thing on a new stand. For PQC, I would like to see a migration strategy in this country. Yeah, so that it's really being kicked off and also supported by, let's say, the management of the various companies. Yeah, so that it goes on. Yeah, and I don't know. So I hope to maybe do a nice showcase with one of the other technologies that have been on my slide. Yeah, and maybe in connection with PQC and PLS. I don't know. So this wiretap coding or something like that. Yeah, to see that a little bit more that we orient a little bit more in the mobile network space. Yeah, because what we talked about in this conference is fiber. Yeah, but we also have to secure our mobile networks.
I just saw now the disconnection, the disconnection, because he dreams, okay, I want it certified. I don't, should be certified, like coming from where? And yes, but this is exactly what we are trying to tell, that for it to be certified, there is something missing, because she could certify it in a way, I can certify it in another way. Yeah, but
that's industry talking.
Yeah, but it's what we are saying is that at the moment there is something a bit serious that we need to tackle. That there are different approaches and by different communities. And then, of course, there is the industry that wants it to certify it as soon as possible because it's a money-generating issue, right? So we are right now here witnessing the problem. Because what would you care how we come up with a solution for the certification, or you just need it certified? You care?
There was a 3-year initiative where people actually sat down and discussed and worked on that. It has been standardized and now it needs to be certified. I mean, I don't know where the problem now is.
So the problem is that now it's different. Now we have a different technology, and we have different communities with different backgrounds. And we have also come up with this hybridization possible option that we all see that is required. So it's different. So in this,
can I try to bridge the gap here for a second? I think industry in a real world laboratory like you're running, where you're trying to get things into application, you're looking for a way to deploy things in practice. And what you do when you deploy things in practice, you have to use an abstraction, and your abstraction is certification. And where we are coming from, I think, is I don't give a damn about certification. I want it to be actually secure, and you have to tell me or I'm not believing you, which is kind of the critical scientist way of viewing things. I think both have some merit, but I think...
And then you read the PP and challenge the PP, and you add on to that, and then maybe we have to rework on the certification.
Yeah, and there are 5, if you look at the PQC migration, there's a 5-year discussion with flame wars going on and people being changed in the background. People are not entirely sure why. And then DJB, Dan Bernstein, starts like to rate somehow. And I'm speaking to people at conferences who are from NIST, and they're just getting very flustered. And you notice that this entire process of standardization in PQC, for instance, is a uniquely human process. It's not a technical process. And you notice that these people who are at NIST, who might not have published all information, are basically humans who are also very angry. And you just notice it's not just about the technical inputs that come out of that. And now I'm somebody who's developing post-quantum secure protocols. And people keep asking me when I build something, why not just use something called CAS-KDF or Concat-KDF, which is the standardized way of doing post-quantum hybridization, which is, I guess, okay, but lacks a security definition. To me, as a cryptographer, standardization certification is cargo cult. It's keeping cryptology alive that we had 10 years ago, which is why I'm always skeptical when people ask me, why don't you do the standardized stuff? And I'm saying, well, I'm 10 years ahead of that. I'm at the bleeding edge of research. These people standardized what was done 15 years ago. And there's some merit in that, but you need to have the process, the scientific empirical process that can feed into standardization. Standardization isn't something that can stand on its own. It needs to be a summary process. And PQC is quite good at doing that. The NIST PQC standardization process was fantastic, but it's still not sufficient.
That is new in a way. So, as you say, NIST has a great process for the certification of classical cryptography, PQC, but we don't have that background for the QKD. And if we want to hybridize, it is a problem.
I was going to ask before I leave the stage, can we have a round of applause for Yanis, who organized this thing? If you have the time, I would be interested in hearing what you plan for this workshop next year.
Oh. Thanks for that question. So at the moment we are discussing where it is going to be held, yeah? And of course it is my secret plan to keep bugging you until I am able to get what I want, which is a kind of a way of utilizing physical layer security mechanisms in modern networks. And so if yeah, that's my plan. So you know there's more people than just me. There's Christian and Bulat and Uzi who are all organizing this conference, and we even have also a local team which has a representative up there and another representative up there as well. Yes, so they should all stand up also.
Yes, of course. I want to thank my PhD students. They build up the things on Tuesday and on Wednesday, and they take care of the barbecue on Wednesday, and they organize a lot and help a lot. And also from Holger's group, Paul is still there, and Johannes, they both jump in because one of the PhD students got ill, and they immediately say, okay, yes, we will do that. That was really good and really nice, and I enjoy that you help a lot, and thank you a lot again. Yes, and thank you, of course, all to come to Braunschweig here. So it's my first year here, and so we put the EASN very shortly here, and we were surprised that so many people were coming and that we had so many nice and very good discussions. That was really not expected. That was really nice. Thank you to all of you.
As far as next year is concerned, stay tuned. We're still working out the details for the location. We would like, since the ACN has been held in Europe for the last, this is the fourth association of it. No. Oh yes, Taipei. Yeah, correct. So yeah, so we had three in Europe, one in Asia, and I would love to try to do this in North America next year in the USA. Now, stay tuned for that. We're working on details, and it might stay in Europe for all that matters, in case things don't work out. But yeah.
Yes, thank you. I really think that the workshop keeps getting better every year. So I have great expectations for next year. And I think really the talks were great. The discussions were terrific. And I hope to see to see you all, see more people next year. Thanks, everyone.